Hey, good evening, everyone, and thank you so much for having me here at ING. So today I want to talk about Arrow, and Urs already showed us a lot of things that we can do in Kotlin around functional programming, but I want to specifically talk about Arrow 2.0 and the focus that we had of innovating functional programming in Kotlin. So, So before I get started, who am I? I am Simon. I am from Antwerp, Belgium. I've been working with Kotlin since 2015 on the back end, on the front end, with functional programming, object-oriented programming, and a mixture of both. You can find me on GitHub, Twitter. I am very active in open source, not only in Arrow, also in other projects in Kotlin. You can also find me on GitLab, and I would also like to send you or share the Arrow website with all of you. At the end of the talk, I will share both my slides and all the code samples that we're going to go over through the presentation. So, first of all, why does Arrow exist in Kotlin? Kotlin already offers us a lot of really powerful tools to write type-safe code or make our code more type-safe. We have the collections API, we have seal classes, data classes, value classes. In the future, we have context parameters, and today I want to focus a little bit about DSLs. So, sometimes we want to take our type safety further than what the standard library offers us, and this is where Arrow comes in. And to recap how DSLs work and what are the benefits, I'm going to talk about the smallest module in Arrow, which is the Autoclose module. And the Autoclose module provides a DSL for the newly added auto-closable type in Kotlin 1.8 in multi-platform, and allows you to elegantly work with auto-closables. So here we have two independent auto-closable types, a data source and a tracing type, which are independent of each other, and we need to use both of them in our program. So if we read the official documentation, it states that it is not recommended to use the close method directly, but instead they recommend to use the use method. And as we can see here, if we have independent resources, we have to nest them, and this creates callback hell. So we can fix this callback hell using a DSL, right? So here we have the Autoclose scope DSL from Arrow, and it allows us to install auto-closables, in this case our data source and our tracing type, in an imperative way, right? So it has removed the need for nesting, and it still gives us all the same guarantees as the previous snippet, right? So here our data source will be installed, our tracing source will be installed. If anything goes wrong, we are guaranteed that all the installed auto-closables are closed correctly and all the exceptions are handled correctly as well. So that's really great. And here, yeah, we see our typical DSL method. It's not the first time that we've seen it today. Anton has also shared it in the lambda with receiver, right? So here we have a DSL from Kotlin coroutines, a structured concurrency DSL. And we can here see that the receiver type is coroutine scope. So that means that inside of the run blocking function, we will have access to all the functionality that is provided by coroutine scope, which is launch and async. And if anything goes wrong, then the exception will be rethrown, and if a value of A is returned, the function returns the value of A. So the DSL that we just saw looks exactly the same. So we have a function with a lambda with receiver, but this time our lambda with receiver is the Autoclose scope type. So what does the Autoclose scope type allow us to do? Well, it is a very simple interface with, in this case, the install method, which we've already seen. But most DSLs, actually all DSLs in Arrow, are all defined in a single abstract method. And here the single abstract method is the Autoclose method, which is a generic way or a generic signature of acquiring a resource or an autoclosable type, and then at some point in the future, finalizing that value or autoclosable type of A with a potential exception that occurred. Right? So that allows us to implement install from this generic function, but it also allows you to install or integrate third-party types, types that you do not own, that might not implement autoclosable. Perhaps you're integrating with Kotlin JS or Kotlin native, which does not have autoclosable, and this avoids the need for wrapping all these types. So here we can see again that by just using a very simple interface with a single abstract method and a very simple function, we have created a DSL which removed the callback health from nesting our use functions. So to conclude, the Autoclose scope DSL gives us a very elegant way or a very simple way to write imperative code when we're working with autoclosables. It avoids nesting and it gives us the exact same guarantees as the use functions. And what I think is important, and I'm going to come back to that several times, it allows you to bring your own types, right? So it allows integrating with third-party types. And that brings us back to our original overview, and maybe the best known or the most notorious library in the Arrow ecosystem, which is Arrow Core. And here you can see a list with all the types that you can find in Arrow 2.0. And for those that are familiar with functional programming or familiar with Arrow from the past, you will notice that this list is quite short. And today I want to focus on the race DSL specifically, but you can also find an either type, which Urs showed non-empty collections in the cases that you want to guarantee that a single element is always available. An inclusive OR type, which is similar to either, but it can be both left and right. Tuples for when you need more than just pair or triple, and option. But with option, I want to be very clear that there's a huge disclaimer both in the KDoc and on the website that we do not recommend using it. The reason that we have it is because some Java libraries do not allow null values in their generic type. And in those cases, you need to wrap in option or optional. And we had so many feature requests from our users working with Project Reactor, which has this issue, that wanted us to keep option, and therefore option is still there, but it is recommended, if possible, to use nullable types. Well, so as I mentioned, we removed quite some stuff from Arrow towards Arrow 2.0, but we of course didn't want to leave anyone behind, right? So there's a lot of people that really like FlatMap, that are very familiar with FlatMap, and I want to continue using FlatMap. And therefore, when we were announcing these deprecations and these features, the Quiver library was released by Cash App. And they actually added more of these traditional functional programming operators on top of Arrow. So this was a great opportunity for us to get together with the Quiver team and say, okay, these are the functions that we do not want anymore. Shall we move them to the Quiver project such that all the users can continue working in their preferred style? But we did not want to promote it as first party from Arrow itself. So, since we are talking about controversial topics, let's talk about typed error handling, which is, again, I think the most controversial feature in Arrow. And I don't want to talk about monads or wrappers, so I'm just going to talk about DSLs. And in this example, I want to talk about a premium user registration flow, right? So we need to register a new user into the database, and we need to receive a payment for that user. So here, we just have some vanilla Kotlin code using exceptions. So we have a user's exist exception, which is a runtime exception. And if in case the user already exists, well, the unique violation or the user exists exception is thrown. But what are some common caveats? Well, there's also, first of all, we can capture the exception. We can recover from it. It's pretty straightforward. I think it is fundamental behavior that almost everybody understands, but Kotlin does not have checked exceptions, right? So there's nothing forcing us to ever catch that exception, and on Android that will most likely result in a crash, and on a server that will hopefully result in a 500 internal ambiguous error, even though that's also not great. If you've written proper tests, and hopefully you've caught that before production, but maybe you want to shorten your feedback cycle from testing to compile time, or maybe you want to protect crucial features like payment or registering premium users, because those are flows that are important to be smooth and progress successfully. So there's many reasons why you might want to do this. So how can we do this? Well, I already mentioned that all the DSLs work with a single abstract method interface, and for typed error handling, this is what the interface looks like. So we have a raise interface which takes a generic value of error, can be any value of error, does not have to implement a throwable hierarchy, and you can raise a value of that error type into the DSL. What is important here to remember is that the raise function returns nothing. Who here is familiar with nothing? Okay, a lot of people. Nothing means that it will never return a value, right? So you're probably most familiar with nothing from throwing an exception. If you throw an exception, it also never returns a value. So this is what our refactored snippet might look like. So our user exists error now became a data class, and it no longer has to extend the throwable hierarchy, but as a downside, our function now has this extension receiver of raise for the user exists error. But having that extension receiver allows us to call the raise function inside of the function body, which is pretty cool. And we can also see that we are expecting a user in the return type, but since our raise returns nothing, the compiler is happy, right? It never returns a value, so it might as well be a user that never gets returned. But yeah, I'm not a big fan of the raise in the extension receiver, so let's see what we can do. And we cannot really do this yet, but context parameters in the future will allow us to move raise to the context parameters, and that will free up the extension receiver for more useful things, as we'll see in a little bit. For those that might know me, I've talked a lot about context parameters in the last 2 years. There's a lot of pros and a lot of cons. There's a lot of people in favor, a lot of people against them. They will allow us to do many, many really cool things. Even if you're not going to use them in your business applications, you can build really cool libraries and DSLs using them. And I also want to emphasize for those that are concerned, we are still going to have to hold and use best practices, right? Context parameters is not a shortcut. Shortcuts do not exist in software, right? We still need to hide dependencies behind interfaces and all the other best practices that we're used to. So how do we call that code? Well, Anton also talked about builders. We already saw the unblocking builder. We saw the Autoclose code builder. Here we have the recover builder for the raise DSL. And instead of a single lambda, this is the first builder that takes 2 lambdas. And in the first lambda, we'll be able to call a raise function, right? So it provides that raise value in the receiver of that lambda, the first lambda, and it expects a value of A as a result, right? So the first lambda says, okay, I'm going to execute a program that results in a value of A, and there's going to potentially a raised error. And in the second lambda, you need to provide an error handler for that potentially raised error, right? And that's going to make sure that you can never call a raise-based program without also handling the error. So this is kind of like typed exceptions, but in a Kotlin DSL jacket. So this is what it looks like to call our insert user function. We open a recover block. We call our insert user, which here we can see that the recover function provides the raise for the user exists, and then in a second lambda, we can handle the error. And just like exceptions, there's a lot of code you can call in that first lambda, so your entire code base could be called in that lambda. That is just how you structure code. And what we've implemented here is effectively insert user or no, right? We are just providing a no fallback. So, also something that Urs mentioned is when should you use exceptions versus typed errors? And first I want to say that, well, if you're using exceptions anywhere, that's perfectly valid, right? So I'm not going to say that it's wrong, not at all. But if you want to use typed error handling, there's a general rule of thumb that works very well, right? So we don't want to turn everything into a typed error. As Urs already mentioned, when things are truly exceptional, we do not want to make them part of our business domain, right? So things like thread death or virtual machine error, we are never interested in recovering from them. As a matter of fact, recovering from these fatal exceptions is almost never valid. And then there's this second kind of exceptions, or a second category of exception: network timeouts, services being temporarily down. We can attempt to recover from them, but we are going to categorize them in, let's say, a resilience category, which I will also cover in a little bit. So what do we actually want to turn into typed errors? Well, things that are important for our domain, right? So, for example, a user already existing, you cannot create two premium users for the same username. Those are things that are really critical to our domain. So, in the example of inserting our user, let's see how we can implement that function. So here we have our insert user function from before, and at some point, if the user already exists, our database is going to throw an SQL exception, and at that point we're going to have to figure out if it's a unique violation or not, right? So we wrap our database code in try catch, and if any SQL exception occurs, we are going to try and check if it's a unique violation. In the case that it's a unique violation, we construct the user exists error, and we raise it into the DSL. And in all the other cases, we're just going to propagate the exception because we're going to rely on it later for resilience. Oh, and maybe one more thing here. Well, if you just look at the method body, so if we ignore the context, looks almost identical to exception-based code, right? If we replace the raise with a throws, this could have just as well been exception-based code. So no flat maps. So how do we model errors, right? This is also a question that I commonly get. And it seems that once we no longer have to extend the throwable hierarchy, we very quickly grab to sealed hierarchies, as Urs also told, which actually many people are also using with exceptions, right? So it seems to be a very common technique. And there is 3 techniques applicable. Well, the first one would be model all your domains in a single, all your errors for your entire application in a single sealed interface, but that's not going to model or scale very well. So typically we want to split them based on use case or domain. If you're following domain-driven design or some other architecture, we want to split things in our layers, and then we're going to apply a technique what I'm going to call layering, which we'll see in a second. And then finally, context parameters is going to give us some more superpowers. So our user registration, right? So here we have a very simple sealed interface. When we are registering our user, 2 things can go wrong. Well, our user can already exist. We already covered that, but the username can also be missing from the request. And we are, in this case, also going to turn that into a typed error. And that function could look like this. And I've omitted the function body because it's not important here. But I've created an extension function on HTTP request such that we get elegant syntax. And I've constrained my function that it can also raise a username missing, right? So inside of our function body, it's not too incredibly hard to imagine. We're going to attempt to get the username from the parameters. In the case it's not present, we're going to raise the username missing error. And similar for our payments, so for receiving our payment for the premium user, we're going to define a separate new sealed hierarchy. And in this case, I'm only taking into account 2 critical errors: an expired credit card or not having sufficient funds, right? This is just for example reasons. And we can then implement our payment function like this. So I again have an extension function on a given user, the user that we have inserted into the database, and we are going to receive a payment. In the case of success, it's not going to return anything, but in the case something goes wrong, we are going to raise our payment errors. Right, and this is really critical for us, right? Because I mentioned before, we really do not want people dropping out of the payment process because it's too cumbersome. It needs to be really smooth. Error messages need to be really precise. So it's for us really crucial that every independent error gives a very specific error message, right? And this is why we've turned them into typed errors. So, you know, I was talking about using this technique without context parameters. So here I've again introduced arrays. Oh, sorry. No. So here we have our route function, and we're working without context parameters. So I have again introduced arrays into the extension receiver, right? And here we have an incoming request, and we have an outgoing response, right? So this is a route handler. And inside of our function body, we are calling all the functions that we have just defined, right? But if you look at this code, you can see, well, this looks, or this might look like any ordinary Kotlin function. Again, if you want to ignore the extension receiver, if you just look at the function body, this could have been any vanilla Kotlin code. But actually a lot is going on here, right? Because our username was an extension on the HTTP request, and it was raising the, oh, actually I missed a slide, I'm so sorry. Yeah, sorry, I missed a slide. The technique that I call layering, sorry. So we have our two independent domains, our user error and our payment error, but now we need to bring them together somehow in our server's layer, right? And this is what I do with a technique that I call layering. So we introduce a new SILT interface that connects these two layers together, right? Which is exactly what we do in the service layer, right? So here we define a user registration error, and all the errors that can occur inside are all the user errors and all the payment errors. So we've now effectively created a new hierarchy that couples everything together. And this is really neat, right? Because here I'm using the service layer interface, which means all the errors from the user and the payment can occur inside. But that also allows us to call all these functions inside, right? So what is very interesting here is that the subtype relationship between user registration error and the errors that were defined on the independent functions is respected, right? So the subtyping is respected, and we can call all the children of our error hierarchy, right? So to begin again from zero from this slide, here we can see in the function body that we can call our functions just like we normally would. But here, in case the username is missing, it will raise the username missing error. In the case that the user already exists, it will raise the user exists error. And for the payment, it will raise all the payment errors. But if everything succeeds, it will return the created HTTP response. There's no flat maps. There is nothing special, just simple function invocation and imperative code. So context parameters allow us to get rid of all that boilerplate. Right, so context parameters will allow us to independently define DSLs or capabilities and handle or resolve them independently of each other, which is extremely powerful, as there is no alternative to this in traditional functional programming. For example, if you're working with monad transformers, you will have a transformer for suspend, one for raise, a second one for raise, and you will end up with 3 to 4 monads inside of your block, right? Which translated to 3 flat maps and a map function. But all of that is gone here, right? So this is extremely powerful. And we can see this pattern not only in Kotlin, but also other functional languages are evolving or converging to this idea. And also, if you notice, the function bodies stayed exactly the same as our previous slide. So this is a bit of an opinion slide. Why do I think that this fits so well into the language? Well, Kotlin actually already has a lot of these patterns available in the language. We have nullable types, and if you squint your eyes a little bit, it looks very similar to option, but in a flattened style. If we look at suspend, and Urs also already mentioned that suspend allows us to flatten mono, allows us to flatten completable futures, Java, and much more. If you look at the Kotlin flow data type, and if you look at the builder for the Kotlin flow data type, you will actually see that it's also a DSL with the exact same signature as all the other DSLs that we've seen today, right? So it's a Lambda with a receiver, right? And that powers the Kotlin flow data type. And finally, we can see how Kotlin kind of doubles down on this idea of DSLs by introducing context parameters, which is going to allow not only Arrow, but also the language and other libraries to take these DSLs much further than what we can do today. And here is a small example of how we can use structured concurrency in Kotlin coroutines to write or integrate a reactor from the Azure SDK with Redis using completable futures, delay from the Kotlin coroutines DSL, and a custom async third-party type, and we can all integrate them very neatly in an imperative way. And if you've ever had to integrate 4 different concurrency frameworks, then you know how nightmarish that can be. So this is really like having a superpower, right? We can simply write imperative code, and it just does what it needs to do. And similarly, I feel that Race does a very similar thing, right? We allow, as mentioned in the beginning with Autoclose, to bring your own types, right? So Race also allows you to bring your own types. And here we can see that we integrate with the either type, we can integrate with the result type that Urs showed. We have specific DSL functions here like ensure not null and ensure. And we can also integrate with third-party types here, a type coming from the Quiver library, right? So it allows you to seamlessly integrate with all different kinds of error types that you might have out there. And the final question is, how does all of this work with third-party DSLs? And this is typically asked in relation to database and database transactions because they rely on exceptions to roll back in case something goes wrong. But the Kotlin language actually has a very specific contract, especially for this. So when a coroutine cancels itself, it is required to throw cancellation exception such that it can show to the outside world that it was canceled. And that is exactly what's happening here, right? So if the insert user fails and raises the user exists error, then the transaction will see a cancellation and it will actually also roll back the transaction, right? So we get seamless interop with third-party APIs thanks to the contracts into the Kotlin language. So to conclude, typed error handling allows us to compile time check the unhappy path if and when you want to. It allows you to bring your own types, and it has automatic interrupt with the entire ecosystem, which I think is crucial for all users. It elegantly fits into the language, reusing techniques from the Kotlin standard library and Kotlin coroutines. And while not covered today, it also allows you to handle errors in many different ways, like error accumulation for validation or whatnot. Yeah, and one thing that we've not yet covered was resilience. When we talk about resilience, we very quickly get to Kotlin coroutines. And that brings us to a new category of modules in the Arrow organization, which is Arrow effects. And Arrow effects has a couple of large modules, as you can see here. The resource module is the same as the Autoclose module, but it has support for suspend and cancellation. FX coroutines offers high-level DSLs for racing, parallel operations, but also concurrent data types like countdown latches of cyclical barriers. We have collectors, which is like Java collectors, but for Kotlin coroutines to build powerful and complex transformation data pipelines. We have STM, which is software transactional memory, which is an alternative to atomics, but that probably deserves a talk on its own. But today I want to focus on resilience, because I think that's an issue that we have to deal with on a daily basis. So here is maybe an imperative snippet of what an exponential backoff might look like. And if you see this snippet, I think it's immediately clear for everyone. It's quite complex, right? We have multiple vars, we have unsafe null casting at the end, we have an infinite loop using isActive. There's a lot going on. It's quite complex to read and understand. So let's see how we can improve on that. So error resilience has a schedule type that allows you to describe what the schedule needs to behave like. And in this case, we construct the same schedule as on the previous slide. So we have an exponential schedule with a base delay, and it needs to recurse for a max amount of retries. And then we are going to retry our insert user function. What is interesting here is this is the insert user function from before. If it raises the user exists error, it will not be retried, right? So here it will only be retried for SQL exceptions. But retrying is actually very hard. And when we are doing exponential backoff policies like this, we very easily turn into overlapping retries. So we have to build a more complex schedule. We need to introduce randomness, and we can do that with jittered, right? And jitter introduces some randomness, which can be configured and tested and whatnot. And it allows you to make sure that the retry intervals are not scheduled at exactly the same times, preventing overloading the system even more and allowing it to recover more organically, right? And that's exactly what we want from resilience. But retrying database operations is also really hard, right? And there's a lot of database operations that we cannot retry at all, right? So we would also like to be able to attach a predicate that says, okay, only when the exception meets these certain scenarios, you can actually retry. So here we say that while the isRetriable predicate is true, the schedule can continue retrying, but once it is false, it needs to stop retrying and rethrow the last exception it saw. Finally, we can also reuse the schedule for raise, right? So here I'm using retry raise, and it allows us to retry typed errors, right? So we can use schedules both for retrying exceptions, but also for retrying our business or business typed errors. And finally, a scheduler can also be reused for repetition, right? So this is like the repeat function that Anton also showed earlier, but on steroids, right? So for example, in this case, I need to interact with a very flaky API, and I hope you don't have to do that. But here I'm saying, okay, I've seen that every 2 or 3 times I get a correct response from my API, so I'm going to attempt 5 times until I get a correct response, right? And that makes it very convenient to continuously repeat an operation or for polling or whatever nastiness you have to do with repetition. So, to conclude this section, schedule allows us to split the scheduling logic from our actual business logic. It allows for very easily building very complex schedules by just calling these builder methods. It can be used for repeating and retrying not only exceptions, but also typed errors. And as a bonus, since it's an immutable description, it's very easy to inject, reuse, inject for testing. There is also support for Kotlin's coroutines test, and there's also support for retrying Kotlin's flows, right? So there's a lot of stuff it does out of the box. Which brings us to our second last topic. Well, we are registering our premium user, but let's say that due to some complexity in our system, we first need to insert the user, and only then we can receive the payment. But if the payment fails, the user cannot be in our database. And who is a backend developer here? Okay, a lot of you. So, well, a lot of you might have also guessed the problem is distributed transactions, right? We insert a user in our database and we need to make a call to a third-party service. So, well, there's 2 things we can do. Sagas for distributed transactions or transactions. Let's just see both. So first I'm going to define a new function because I like all my functions to be very small. So I create a new function, insert user or rollback, and we are going to wrap our original function, but here I've added an additional type in my context parameters, right? So here I say for this function, or to call this function, you need to be able to provide a Saga. And we're not going to look at the interface, but the Saga scope is, again, an interface with a single abstract method, in this case, the Saga method, and it allows you to define an action, which in this case is inserting the user, and it also allows you to define a compensating action, which is deleting or rolling or attempting to roll back the user, right? I'm saying attempting to roll back because, yeah, Saga's distributed transactions problematic. I'm not going to go into that, but so how can we actually use this code now? So we replace our insert user function with our insert user or rollback function, but the Kotlin compiler is now not happy, right? So we only have raise in our context, and the Kotlin compiler says, hey, you want to call this function, but I need a Saga to be available. So the simplest thing that I can do here, I want to keep my Saga as short as possible. So within my function, I'm just going to create the Saga and run it as a transaction, right? That's great. Now, if the payment fails, our user will be attempted to be deleted. So what if we really need that guarantee that the user will always be rolled back? Well, we don't really have another option but to wrap our entire route in a transaction, which is also a very popular pattern. So let's see how we can do that in a typed way in Kotlin. Well, actually, we don't have to do anything except adding the transaction error context parameter. And the transaction error context parameter here comes from the exposed ORM framework. It can also be used with SQLite. I'm not sure about other frameworks, but all the frameworks that offer a transaction DSL within a transaction type can be leveraged in this way. And now the compiler will actually also make sure that this function is never called outside of a transaction, right? Which is pretty neat. So we've seen a couple different ways to define our route. How do we actually call everything in the end? So here I have a Ktor route, but those details are irrelevant. We needed to provide both our raise and our transaction, and we can do that in this way, right? So we call two builders to provide both our context, and then we call our own function inside. And there's one thing here that I want to emphasize, and that is that the order of a raise and transaction is actually not defined. Right? So in our previous slides, right, we have raise first and then transaction second. That can be switched around. There is no ordering in the arguments within the context block, which also means that there is no order defined in how we call these builders. Right? But a transaction is only rolled back if it sees an exception or an error, right? So if you want to make sure that the transaction rollbacks the user, you need to make sure that the raise is handled outside of the transaction, just like you would do with try, catch, and exceptions. So to wrap up arrow effects, the Saga pattern DSL, again, shows us a very elegant way of using DSLs to solve complex problems. But I want to emphasize avoid distributed transactions, right? This was not a promotional talk for Sagas, not at all. Avoid distributed transactions wherever possible. But I want to emphasize that all these builders and DSLs in Arrow are extremely efficient. So if you want to build your own stuff on top, you very easily can, right? So you can use these as building blocks for building other stuff. And then finally, immutability. I think immutability is important for everyone in Kotlin, right? Whether you're doing front-end or back-end, you should be trying to use immutable data everywhere in your application. But dealing with immutable data can be cumbersome, and this is where Arrow Optics comes in. And I think Arrow Optics is kind of unique in the sense that it, I think, more complements the language than the Kotlin Standard Library or Kotlin Xcore teams. Because if we think about immutable data, we think again about data classes, sealed classes, value classes, maybe read-only collections, but mostly about types. And it doesn't really have modules. It has 3 very small integrations for avoiding boilerplate. You can generate boilerplate with KSP or using GVM reflection. And there is a small integration with Compose for those people that have deeply nested UI or view models, and you need to work with them in an elegant way. So here we have an example with 2 simple data classes. We have a product with an identifier and a price, and we have an order item with a product and a quantity. And we need to apply a discount on the product's price. So we need to copy the original item, and then we need to copy the product in the item, and then we can apply a discount function on the price. But yeah, the deeper our data becomes, the more deeply our tree or callback hell becomes. So let's see what we can do about that. And AeroOptics also has a DSL to solve the callback hell. So here we define a path, and the path says that we go from the order item into the product, and from the product into the price, and then we use that path to modify a value given a function, right? And that gives us back an order item with the discounted price. But AeroOptics has much more support than just for data classes. It also has support for collections. So here we have an inventory data class with a collection of products inside. And since we just gave a discount, we need to increase the price. So we are again, digging or copying the inventory. Then we are getting all the items in the inventory, mapping or transforming every product in the items list, and then copying the product to adjust the price, right? And this is even worse than before, because now we've introduced collection logic into our copy blocks, which is really not that great. But we can again solve that with a very simple DSL, right? Which looks exactly the same, right? And I would say the special case here is the every DSL function that was introduced. So we say we're going to dig into all the items into the inventory, and then the every function is going to dig into every item of the list, and then we can select a price that is defined on every item in the list, and again use that path to modify the inventory given a function. But AeroOptics also has support for sealed classes. Right? And I think sealed classes were the worst out of all three, because when we need to, again, apply a discount on the product, we need to first make sure that we have a successful response for the discount to be applied on. So we need to dig into the sealed class and select the success case. If we find the select case, we need to create or copy the success case and dig into the product, and we then need to dig into the product's price to apply the discount, right? So this has become even more complex because we need to deal with the failed case, even though we're not interested in it, but it's always there. But we can solve this again with a simple DSL. So here we have a DSL that says, okay, I'm going to dig, this time not into a value, but into a type, right? So we go from the error or product type into the success type. And then from the success type, we go into its product. We go from the product into its price. And we again use that path to modify a value given a function, right? So we always see that same pattern. We define a path in our data, which can also be stored in a file. And we use that path to modify our data. But this modify looks foreign to a lot of people. So we've introduced a copy DSL on top, such that you can copy any type, not only data classes, but also sealed classes or collections. You can copy them, and you can then use optics to drill into the properties and modify multiple values at once. Right? So this looks very similar to the copy blocks that we have in Kotlin, but it has support for sealed classes, collection, and much more. Right, so I think this is really, really powerful stuff. So to conclude, optics allow us to focus on the business logic and the paths in our data, right, nothing else. Allows us to simplify very complex immutable transformations, but I think this truly belongs in language, right? This is, I think, an issue that all of us encounter, and to make it even worse, I hear from many people that they keep their hierarchies shallow to avoid this kind of code, right? So I think Kotlin should facilitate that and remove that hurdle. And Roman Elizarov, the previous language lead, agreed with me, or well, I agreed with him. He created a keep and a U-track issue explaining in depth what his ideas are for this problem. Alejandro Serrano last year also gave a talk on this topic. And yeah, I hope that in a couple of years we can see something coming into the language. And finally, yeah, what was I hopefully able to share today? Well, Kotlin really loves DSLs, and I think it's apparent everywhere, also after Anton's talk today. And Arrow loves Kotlin for it. DSL allows us to do so many cool stuff, like hide the complexity of functional programming. But I also was hopefully able to show you today that Arrow is very feature-specific, and it tries to split all its features into separate modules so that you can pick and choose what you want when you want it. And there's much more to learn. So I also want to share some links with you. The Arrow people or Arrow community is extremely active on Slack. We are continuously putting a lot of effort into the website. And yeah, you can find the repository, the slides, and the code examples of today at the bottom. Are there any more questions?
Thanks. I actually have a question about layering errors. It's great we have sealed whatever, I mean, like, not whatever interface classes. They have limitations in language that they should be in the same package. Yeah. So in this case, I'm kind of in one package mixing many domains, for example. So what's a solution?
Where do I have it? Yeah, so I typically define them in a single package. There's, yeah, where did I have the slide? So yeah, this is one of the issues, which is why I'm so anxious for context parameters. Sadly, if you really need to define them in separate packages, or even worse, separate modules, then you will have to create a translation layer, which luckily you can very easily inject. I didn't show it here today, but there is an option in the DSL to say, okay, if anything is raised for this type, then automatically transform it using this function.
Thanks.
Hi, I have a quick question. It might be a little off track and not the right question for you, but we use open API generators, right?
Yes.
So do you know if I can use all of this in my code and still be able to translate it into an open API specification?
That's hard to answer without any more details. Well, I know OpenAPI Generator does not have support to generate specific Arrow clients, so that support is not there. But yeah, on the Spring side, it's really not viable to return arrays or an either from an endpoint. You should resolve that to a response entity, or use the techniques that Urs shared. If you want to have them properly shown up in the generated OpenAPI specification from Spring.
Let's say if I'm not using raise, but I'm using either, right?
Yes.
So in that case, it is properly typed into two responses, either this or that. So in that case, would it be possible to?
No, because Spring will consider it a single value, right? So it will actually try to serialize the either and send the either over the network.
Okay. Okay. Cool. Thank you.
All right. Thank you all so much for coming and having me.